you get out your student notes, question 1, it wants to know what the measure of angle 1 is. Well, the measure of angle 1 is simply this. The measure of angle 1 is a central angle. The central angle is always equal to what the degree measurement of the intercepted arc is. In this case, the intercepted arc is x degrees, so the measure of angle 1 is equal to x degrees. If this intercepted arc was, say, 60 degrees, then the measure of angle 1 would equal 60 degrees as well. The next column says, how is it formed? Well, it's formed by two radiuses, or two radii. You have a radius here, and you have a radius here that forms a central angle. And then it talks about the hints and comments. It says the measure of the angle, this angle here, equals the measure of the intercepted arc. So the measure of the angle is equal to the measure of the intercepted arc. It's question 1. Question 2. You have two chords that intersect each other. You have chord AC, chord BD. You have angle 1, angle 2. You have y degrees for that, and you have x degrees for this one over here. Once again, what is the measure of angle 1? Well, if we remember, anytime two lines intersect each other, they form what we call vertical angles. So that means that these two angles are equal to each other. Also, if this is angle 2, we know that whatever angle 2 is, that's equal to this arc angle measurement, and angle 1 is equal to this arc angle measurement. Well, in this case here, I don't have that information. All they do is give me some stuff. So, the formula for this, you have to take, so if we're looking for the measure of angle 1, the formula would be the measure of angle 1 is equal to the sum of the two arc measurements divided by 2. So if we're looking for the measure of angle 1, this would work for the measure of angle 2 as well. But if we're looking for this angle right here, the measure of angle 1, now this is not a central angle. So this is not automatically equal to this. If it was a central angle, yes, but it's not. So the measure of angle 1 is equal to the sum, this arc measurement added up with this arc measurement divided by 2. So for example, if this was 30 and this was 70, we say 30 plus 70, which is 100, divided by 2, the answer would be 50, so the measure of angle 1 would be 50 if they had measurements. It says, how is it formed? Well, it's just formed by two chords that intersect each other. And in the comments, or the hints and comments section, it says, the measure of the angle equals half the sum of the measure of the two intercepted arcs. I think it's easier if you just say like the formula does. The measure of the angle is equal to the sum of the two intercepted arcs divided by 2. Question 3. Question 3. We have an inscribed angle. And it's inscribed angle ABC. And this is angle 3. And this up here is x degrees. They want to know, obviously, what the measure of that angle is. Now, what they would need to remember is, anytime, and this works anytime it's an inscribed angle, and this will work the opposite way as well. The measure of this angle, in this case, it's going to be the measure of angle 3. The measure of angle 3 is going to equal to whatever the intercepted arc is. In this case, it's x degrees, and we're going to take half of it, or we're going to divide by 2. So the measure of an intercepted arc is equal to the measure of an inscribed angle, the measure of an inscribed angle is equal to the measure of this intercepted arc divided by 2. So you got to take half of the intercepted arc. For example, If this was 80, you would take 80 divided by 2, and this would be 40. If that was 80. If it was something else, you'd just still divide by 2, it would be something else. It talks about how is it formed. It says two chords that intersect at a point on the circle. It's an inscribed angle. It's formed by two chords that intersect at a point on the circle. And in the hints and comments section, it says the measure of the angle equals half the intercepted arc, which is exactly what our formula says. The measure of the angle we're looking for is equal to half, which is divided by 2, of the intercepted arc. Question 4. Question 4, you have a chord and you have a point of tangency. A chord and a line of tangent. And it says that from here to here is x degrees, and this right here, it says is angle 3. I got a bad line of tangency there, let me redraw that. This is angle 3. So how do we find angle 3? That's the question. It's the same thing. In this case, you do it the exact same way. The measure of this angle is the same as what the previous question. The measure of angle 3 is going to equal to the degree measurement of the arc divided by 2. It's the same thing. So for example, if this was 50, we take 50 divided by 2 and we get this. And you can say the same thing for the opposite. If this was 25, we would multiply by 2 and we can have the arc measurement. 25 times 2 would be 50. Question number 5. Real quick on question 4, let me give you how it's formed in the comments. It says a tangent chord angle formed by a tangent and a chord at the point of tangency. So we have a chord and we have a line of tangency formed to make this angle here. And if you're looking for this angle, all you do is take the degree measurement of the arc and divide by 2. On the hints and comments, it says measure the angle equals half the intercepted arc. So both questions 3 and questions 4 are the same. Question 5. This is x degrees, this is angle 4, and this is y degrees. Once again, we're looking for the angle measurement. And this works both ways when we're doing this. If you'll look, question 5 there, it says, how do we find this? Well, anytime you have an angle outside of the circle, you have a secant and a tangent working here. One line is secant line and a tangent line. Anytime the angle is outside the circle, it's very simple. You're going to take the bigger of the arcs, in this case it's y, subtract the smaller of the arcs, which is x, and you're going to divide by 2. So in this case, the measure of angle 4 would equal y minus x, and you would divide by 2. So you always take the bigger of the arcs, subtract the smaller arc, and divide by 2, and you will get this outside angle. How is it formed? Once again, it's a tangent secant angle formed by a tangent and a secant at a point outside the circle. In the comment section, measure of the angle equals half the difference of the intercepted arcs. So the measure of the angle equals half the difference of the intercepted arcs. So we subtract the 2, and then we take half, which is divided by 2. You know, if this was 70 and this was 30, for example, 70 minus 30 would be 40, and then we would divide by 2, and then our angle would be 20, for example. Question 6. You have the exact same thing, only it's flipped. So we have the same, almost the exact same diagram. The only difference now is that it's flipped. So now it's over here. It goes up like this, and it comes through the line. So now you got 2 secants forming this angle 4 over here, and we have x degrees there, and we have y degrees there. It's the same thing. It doesn't matter if it's 2 secants, or if it's a tangent, or if it's 2 tangents. As long as the angle that you're looking for is outside of the circle, it's the same formula. It's the measure of the angle, which in this case is angle 4. You take the bigger of the arcs first, so subtract this arc y minus the smaller arc x, and then we divide by 2. Number 7 is the same way. It's the exact same way for number 7. The only difference on number 7 is you have 2 tangents. So we have a tangent line out here, and we have a tangent line there. You have the y. You got this humongous arc going all the way around here, and you got the little arc back here, and this is angle 4. Same thing. Measure angle 4 is equal to the big arc minus the small arc first, then we divide by 2. Remember, on all 3 of those, 5, 6, and 7, in the comment section, the measure of the angle equals half the difference of the intercepted arc. Now you have another sheet there. Let's look at the example 1, example 2, example 3, and example 4. Example 1, they don't give you anything. You'll have to use a protractor if you wanted to do this. I've already done it, so I'll just share the details with you. If you measure this, you'll find out that this is 90 degrees. So what we've learned so far is this is a central angle, and the central angle is going to equal to the intercepted arc. So that's going to be 90 degrees as well. This here, if you measure, it's going to be 65. And we know that this is going to be 65 as well because of central angles. And then we go back to what we learned earlier in the very first portion of this. And you ask yourself, what is the measurement of this little bitty arc out here going to be? Well, it's not 65. If this was the central angle, then yes, that would be fine. But it's not. Okay? So see what you get when you measure this little section right here. Remember the formulas. It is this angle, this arc, plus this arc, and you would have to divide by 2. Look at example 2. Example 2, you have FH. And it says that this is 130 degrees. This is G, the point of tendency, and says this is 122 degrees. It says find the measure of angle EFH. So E from here, EFH. EFH. We want to know what this is right here. This angle. Okay? Well, look at the two things. What do we know? Find the measure of angle EFH, and it wants to find the measure of arc FG. Well, our first clue right here, this part's 130. And then this angle right here is 122. Remember your rules. What does that look like? Okay, so go back and look at all of your examples there. This right here, this is 122 degrees. Remember, if you have this, you can work it backwards. The measure of this angle is equal to the measure of the angle equals half of the intercepted arc. Okay, well let's look at this. What's the intercepted arc? If we want this angle right here, what's the measure of half the intercepted arc? Well, if that's 130, half of that, 130 divided by 2, last time I checked that looks like that's about 65 degrees. This is very, very simple. So EFH is 65 degrees. Now they want to find the measure of arc FG. So they want to know how far it is from here all the way to here. Well, let's remember this. If this is 122, and that's the point of tangency, we have a straight line going on here. That's kind of important. So if that's 122, how much is this going to be? Can we use that method? Can we use the straight line there to say, hey, if that's 122, then this side's got to be just the opposite? Sure. 180 minus 122, that gives you 58. So we know automatically that that is 58 degrees. Well, once again, let's work it backwards. They want to know what the arc from F to G is. I can multiply that by 2. If I know the arc and I divided by 2 to get this, then if I know this, I can multiply 2 and work it backwards. So 58 times 2 gives me 116. So I know that from arc FG, the measure of arc FG is equal to 116 degrees. Example 3 and example 4. Example 3 says 2 of the 6 muscles that control eye movement are attached to the eyeball and intersect behind. So here's the eyeball. They attach. They attach. So the measure of arc AEB. So from here, AEB says it's 225. So from here all the way around is 225 degrees. Well, all the way around is 360, so I automatically know how much this is. This right here, if we subtract from 360, we got 360 minus 225. We subtract that out, we get 35. So I automatically know this is 135, sorry, not 35. So that we know this is 135. It wants to know, find the measure of ACB. So they want to know from here to here to here. Remember our rules. It's outside the circle. So we take the big one minus the little one and divide by 2. So we get 225 minus 135, which is 90 degrees. Take half of 90 degrees, we get 45. So this is a 45 degree angle. So ACB, the measure of angle ACB is equal to 45 degrees. And the last one there, you have the Ferris wheel. You have the Ferris wheel, and you have them outside it, and we have a point of tangency. And it's pointing here, here, and down here. It says an observer watches people riding a Ferris wheel that has 12 equally spaced cars. Find x. They want to know what this is. Well, count. If the whole thing is 360 and we got 12 spaces, 12 equally spaced cars, divide this by 12, that gives me 30. So every individual portion is 30. So now we have to count. We got a Ferris wheel, a Ferris wheel, a Ferris wheel, and a Ferris wheel. So count the spaces. 1, 2, 3, 4, 5. 5 times 30 is 150. Over here, you got 3. You got 1 here, and you got 1 here. So you got a space, and a space. 3 of them. 330, that's in this case here, they're saying this is from here to here is 90. So once again, it's outside. So we take the big one, which is 150, the big arc, minus a little arc of 90 degrees, and then we divide by 2. 150 minus 90 is 60. Divide by 2, you get 30 degrees. So in this case, the measure of angle x is equal to 30 degrees.